Well, hello Internet, and welcome to my C video tutorial. I've received this request numerous times over the past couple years, and today I'm going to make an extremely fast C tutorial. It's actually going to be a couple videos, but either way it's going to be way quicker than anything you've ever seen in your life. And I provide links to all of the code, and I heavily commented it to aid in translation. And I'm going to keep everything very, very simple. So I have an immense amount to do, so let's get into it. Okay, I have a very simple setup here. I'm using Text Wrangler. If you're on Windows, you can use Notepad++, and everything's pretty much exactly the same. And over here, I have the terminal, or if you're using a Windows machine, you could, of course, use the command line. And I'm just going to be typing in the code here, saving it, and then executing it over here. So, let's go. Alright, so to create a multi-line comment, you would just put a / and a star, and then whatever you wanted to type in here, and there you are. There's your multi-line comment. A single line comment is just going to be double dashes, very much like you are used to. Then what I'm going to need to do is use include, and the reason why is I'm going to be using some functions like printf and scanf, which are going to allow us to print to the screen and also take input from the users. And to do that, I need to use include to include certain code. And for printf and scanf specifically, I need standard input output H, and what this is going to do, this include statement, it is going to take that code and stick it wherever the include statement is. And that is pretty much what include does. I'm also going to do a little bit with strings, and strings are a little bit weird with C, and to do that we're going to need that library. I'm also going to define a constant, and it is common whenever you define constants using the define keyword that you put your constant's name in uppercase letters. And what this is going to do is at compile time, anytime it sees my name, it is just going to replace it with this string right there. So, moving along. Another thing every program in C is going to need is a main function. And the reason why is the main function is going to be where the computer starts executing your code. And if you put any other functions, which we're not going to get into functions in this tutorial, but if you put any more functions that are not referenced from main, they will never execute. And to define main, you just type in main, and then you're going to put curly brackets, just like that. And that is how main is defined. And if you can't see this, you can view it in full screen because it's a 1080p video. Another thing, since I'm up here, I'd like to show you how to use or create a global variable. And a global variable is going to be defined outside of main, and it is going to be accessible to every single function in the entire program. So that's all that means. That's a global variable. And more specifically, this right here would be a variable that is local to the main function. And just to put it really simple, a variable is just a box in memory that is going to allow you to save all of your data. And whenever you are creating names for your variables, you have to start them off using a letter. I'm just going to put in here first letter. You can type in any variable name you want, of course. And then in this situation, we're going to create a character, and we use single quotes to create that said character. Also, however, you can use uppercase letters, as you can see right here, and you could use underscores, and you could also use numbers inside of your variable names, just as long as this first guy right here is a letter. Characters, specifically, which is a specific variable type, are going to allow you to hold any of 256 different characters, and like I said before, they need to be surrounded by single quote or an apostrophe. And of course you can put a number inside of there, however you would not be able to use that number in calculations and so forth because it's considered a character and not a number. An integer is going to be any whole number that does not have any decimal places, either positive or negative, and they are going to be between negative 32,768 to 32,768 positive. That is your possible values if you're creating an integer. And I'm just going to create one called age, and I'm going to type in 38, and there we go. Now, if you need to use an integer that is bigger than what I said was provided with the integer, which just think 32,000, what you're going to need to do is use what are called long ints. And let's just create ourselves a super big number, and let's just make it negative 32,767,000, and don't put commas inside of here. You can't do that. And the long int is going to provide you with the ability to create even bigger numbers. Now, if you want to use decimals, then you're going to want to create what are known as floats, which can be positive or negative, and of course they can contain decimals. And let's just say pi value is equal to 3.14159, da 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 da. And that would be a valid type you could use inside of there. And a float can be as big as 38 decimal points in length, roughly. If you need to use something that's even bigger than that, then you can use a double. And let's just say really big pi is equal to, and I'm just going to copy this guy right here, paste that in there, and yes, I know that this is not pi, so you don't need to tell me, I'm just typing that in there just to save ourselves some time. And that is what the doubles are for. Printf, which I referred to earlier, is going to allow us to print information to the screen, and something you're going to see a lot is this backslash and n. What that's going to do is force a line return, or to skip a line. That's what that guy's for. And as you're going to find, most of the C function names that you're going to see are not going to contain uppercase letters. However, that doesn't mean you can't use them yourself. And in reference to backslash n, remember I just said skips a line. We're also going to have backslash t, and what that's going to do is create a tab of different lengths depending upon the computer that you're using. If you ever want to use a backslash inside of your printf, just put 2 backslashes. And then of course if you ever want to use a regular quote, just put a backslash and a quote. So those are all those guys. So let's try to actually come in here and actually use printf, because printf's a little bit different than maybe some things that you've seen in the past. We're going to put double quotes inside of here again. And now let's just do something simple, like let's just say this will print to screen, and then we'll just put in here 2 backslashes, 2 line breaks anyway. And now that we have that all set up, we're going to save that. And like I said, C tutorial1.c. Then we're going to bounce over here inside of the terminal. And to execute our program, first, let's just make sure it's there. There it is. And to compile, what we're going to do is go GCC, and then we're going to take this guy right here, paste it inside of there. Here is your actual way of making this all show up. And of course, it's going to end with the .c, and hit enter. And whenever you do that, you're now going to see that a.out shows up there, // and we're going to go a.out. This will print the screen, prints out to the screen. So that's how we handle printf. Let's do a couple more things with printf. Let's say, for example, we want to take our age that we defined up here, this 38, and we want to print that out. How exactly are we going to do it? Well, it's a little bit different than maybe you've seen in other programs. I'm going to say I am, and then I'm going to put in a % and a D, and then I'm going to type in years old, put 2 new lines inside of there, close that quote off, and then type in age. And that % and D is what's going to be used whenever you want to use integers inside of C, or you want to print out integers anyway. We're going to have to come back over here, and we're going to have to recompile that and then execute. Now you can see I am 38 years old. So wherever we have the % and the D, age is going to be taken from here and put over there. So that's how that's going to work. And we are going to use different conversion characters, that's what these guys are called, depending upon the different data types that we want to use. So I'm just going to copy this guy right here. And let's say that I want to print out a long int inside of here. I'll just type in big number. Then we're going to put in a %, and then we're going to put in LD. And then here I'm going to put in super big num, like that. And there you can see, super big num prints out on our screen. Have a couple of these different conversion characters that we're going to be working with here. Let's print out our little pi value. Pi is equal to. And to print out a float, it's a little bit different. What we're going to do here is a %, just like always. However, if we want to define exactly how many decimal places we want to show up, we're going to put a period here, or a decimal. And then let's say that I want 5 to show up. That's exactly how that was set up. Come in here, type in pi value, which is the name of our variable. And of course, don't forget to put the F inside of there next to float. Come over here, like that, execute it, and there you can see that pi printed out, and indeed it did print out 5 decimal places, which is nice. Now remember, we also have doubles inside of here. Well, doubles actually use the F as well. Let's just come up here and look at it. There's a whole bunch of different numbers. There's at least 15 of them there. Here I'm just going to type in big pi is equal to, and remember I said we're still going to use F with the float, except in this situation I'm going to type in 0.15 for 15 decimal places, and then here I'm going to type in really big pi. Compile, execute. And there you can see, really big pie printed out, and I'm sure there's 15 numbers there. I'm not going to bother counting them, just know there is. So that's how you work with doubles. Remember, doubles and floats, the same exact thing. We're still going to use F for both of them. Characters, of course, are also going to be different. So let's say something like the first letter in my name is, and then we're going to come in here and put a percent sign again, but this time we're going to put a C inside of there. And then we're going to type in first letter for that, which of course is this guy up here, which is going to be the letter D. I'll save it, execute, and there you go. First letter in my name is D. So moving right along here. If we want to print out a string, I'm going to show you a couple different ways to do this. But let's say my name is, then I'm going to put a percent sign and an S. And if I'm going to do it this way, I'm going to type in Derek, like that. And there you can see, my name is Derek, shows up there on our screen. Now to create a string, this is where it gets a little bit weird. You're actually going to create a character array. So let's say that I wanted to create a character array or a string called my name. Well, I'm going to actually have to create enough spaces inside of it. And in C, everything starts at the 0 index and works its way up. So just think of the array as a bunch of boxes, just like before. And there's going to be a letter in each one of those boxes. So if I want to do my name, I'm going to need at least 12 characters. 5 for my first name, 1 for the space between my first and last name, and 5 for my last name. And then I'm going to need what is called a string terminator. You have to always provide room for this guy right here, and this is considered one character inside of your string array. Very important. The reason why is that just tells C that this is the end of our string. So always make sure you have enough room for at least one more character whenever you're creating these guys. And then we're going to come in here, I'm going to type in my name like that. And there we go. I just created a string. And you could also do the exact same thing by getting rid of that right there. And it's going to create a string array that's going to be big. It's a character array. I should stop calling it a string array. It's going to create a character array that's going to be big enough to hold this as well as the string terminator. And then, of course, I could come in and do something like my name is, and I can put a percent sign and an S just like before. And in this situation, type in my name. And there you can see my name is Derek Banas. See? Shows up. Now, it would be nice to be able to assign a new value to a character array, but you cannot do that. There's no way that you can set that up to work. So instead, if you want to change the value, you have to use strcpy, string copy, and then put in your string and whatever you want the new value to be. And the reason why we brought in string.h is because of what we're doing right now. So that is how we set it up. So we have that. And there you can see my name is Bob Smith shows up. And we're actually going to delete all this stuff and continue on because I'm going to show you how scanf works. And what scanf is used for is for receiving input from the user. So I'm going to create a new character here and I'm going to call it a middle initial. Then what you're going to want to do almost always is use printf to actually ask a question of the user in regards to what information you actually want. I'm going to say, what is your middle initial? And then we get to scanf. And scanf's a little bit weird. What you're going to want to do here is put a quote and a space, percent sign, and C because we're trying to get a character from the user. And then you're going to want to put an ampersand inside of here, like that. And then wherever you want to save this information that they are going to want to input, which is going to be middle initial, this guy right here. More on the ampersand later on. So that is how you're going to receive input from our users. And then I can come down here and say something like middle initial, and it's going to be a character, of course. And then here we don't need the ampersand, we're just going to put in middle initial. Execute, it's going to say, what is your middle initial? I'm going to say J, and it's going to say middle initial J right there. I probably should have put in a space here, but either way. Now what we're going to do is create a string array, because with scanf you're only going to ever be able to accept one value at a time unless you specifically note that you're going to be getting more than one value at a time. So you tell scanf what's coming in, see, it knows there's a character coming, it doesn't know there's anything else. So even if this was a string, this would not work. And actually you're going to see that strings are handled a little bit different with scanf. So this is basically saying I'm getting one value and I want it saved in this variable. If they would type in more than one character, or more than one number with a space between it, that information would be ignored. And we're going to get into that more later on. So let's create ourselves a character array, and let's call it first name, and I'm going to give it 30 spaces. And yes, you can define more than one variable at a time. And we'll say printf, what is your name? Like that. Actually, I'm going to come up here, throw in a new line just to keep the code a little bit tighter here. And then what I'm going to do is go scanf and quote and space, and then what do I want? I want a string, and then space, and then another string. So you have to define exactly what you want whenever you're using scanf. We're going to be getting into other different ways to receive input later on. So first name and last name is where that data is going to be saved. And then we can do something like printf, your name is %, string, %, character, %, string, new line, and then inside of this we're going to say first name, middle initial, last name, like that and like that. Then we can come over here, execute, what's your middle initial, J, what is your name? I can actually type in my whole name, and there it is. It was smart enough to print out everything in the right order. That's pretty cool. You could also do something like accept slashes inside of here. So let's say I wanted to go int month, day, year, printf, what's your birth date? And remember, you just have to define exactly what scanf needs to look out for whenever it's getting it. So we're going to get a birth date, so that's going to be an integer, and then there's a slash, and then we're going to get another integer, and another forward slash, and another integer. And of course, don't forget to put your quotes inside of there. And then you're going to have your ampersand again, and we're going to have month, day, year. I like that. Let's also throw a couple new lines inside of this. Let's then come down here and go printf. Throw a new line inside of there, and then we're going to say birth date, and we're going to define exactly what is going to go on the screen. So we got that, but we have to put the slash in ourselves, of course. Another slash, two new lines, and then we're going to go month, day, year. What's your middle initial, J? There it is. What's your birth date? 12/21/1974. And there you go. That printed all out that way. Now, of course, there's a whole bunch of different ways you can use mathematics inside of C as well. So let's go and get rid of some of this information. You can perform addition, you can perform subtraction, you can perform multiplication, you can perform division, and sometimes you can perform modulus, which is going to return the remainder of a division between integers. You can't do that with floats. Let's go in here and create a couple of these guys. So I'm going to call this guy number 1, give it a value of 12. This is another way to initialize your different values inside of C. Let's say this is 15, and then let's say this is number answer. And then we're going to create a float, and I'm going to call this decimal 1, give it a value of 1.2, decimal 2, give it a value of 1.5, and then decimal answer again. Come in here, throw a couple different printfs inside of here. Then we're going to go integer, calculation, float, calculation. Put a %d up there, put a %f down here. And then for this guy, what we're going to do, put a comma, of course, and we're going to go num2, and we're going to do a division. And then we're going to come in here and do num1. Come down here, we're going to do a pretty similar thing. We're going to go decimal 2, division, decimal 1. And then for this guy, I'm also going to do a modulus and go num2, modulus, num1. And execute, and there you can see an example of using some math functions inside of C. Now, of course, order of operations is going to matter inside of C as well. So, of course, we're going to have to use parentheses to make our math work the way that we want it to work. So let's say that we come in here and go without parentheses and then perform some calculations like 3 plus 6 times 10, and then this would be with parentheses, and execute, and you can see exactly how that changes. And of course, the order of operations is going to pay the most respect to parentheses. Then it is going to pay attention to the negative sign, the not symbol, which we're going to get into later, increment and decrement, which we're also going to get into later, multiplication, division, modulus, then addition, then subtraction, and of course relational operators, which we'll also get into later. And let's create ourselves a random number and give it a value of 1. Now there's a whole bunch of different shortcut ways to perform all of these different operations as well. There's plus equals, and what that's going to do is actually add whatever the number on the right of this, whatever it is, to itself. Let me give you an example rather than just talking about that. Then I'll show you the different shortcuts. Let's say we wanted to go 1 plus equals 2 and then put something inside of there. A shortcut way to add 2 to a number is going to be random num plus equals 2. So that's a little bit of a shortcut. And there you can see 1 plus equals 2 is going to be equal to 3. So it just added 2 to whatever its value was. Now you may ask yourself, well, why didn't I just put random number in here instead of putting in 1 there? You're going to see in a second. The reason why is because of how C performs calculations and so forth and so on. So I'll just put it in here like this. Kind of a neat little thing to think about. And I'm going to go random num. And then I'm going to go random num plus or equal to 2. And you can see that 5 actually shows up. The reason why is it actually performs the calculation before and puts that value in here. And that is the reason why I didn't do things the way that you saw them. And like I said before, the shortcut is available for, of course, doing additions. It's also available if you want to do subtractions from themselves, also multiplications, also divisions, also modulus if you are working with integers. And then if you want to just quickly add 1 to a value, you can just put the variable's name inside of here. So var name plus plus, and what that's going to do is increment it. And then if you put 2 negative signs, that's going to decrement it or decrease it by the value of 1. And that is also another thing that's kind of interesting inside of C. Let's say that we go int example number is equal to 1. I'm going to show you a couple different ways that we can play around with these increments and decrements and things to look out for. Now you remember up here what it did was it performed this calculation first and then took that value, saved it into random number, and then displayed that value on the screen, just like you see here over here. Well, using the increments and decrements, you can actually put those pluses and negatives on different sides of the variable to determine exactly when they are performed. If you want them to be incremented before they are displayed on the screen, put them before the variable. We're just going to come in here like this, and d x num, and then here we're going to put those 2 symbols right there. And then just to see exactly what this looks like, if you put it in a different position, %, d, here we're going to increment after the fact, and actually we're going to change x num back to 1 in the meantime, like that, x num, like this. And there you can see exactly how that works. Here we're going to increment it and then print it out on a screen. And down here, whenever you put the addition or the incrementer after the value, it's going to display it the way that it's originally before this operation, print it to the screen, and then increment it. And like I said before, you can do the same thing with 2 negatives or a decrement. And then the final thing we're going to do here is to show you what it means to cast a value. Very simple to do. I'm going to come in here and create ourselves an integer number example, and I'm going to give it a value of 12. And let's say that I create a float number example 2, give it a value of 1.234. Then let's say I want to go number and print this out here on the screen. Actually, let's do it a little bit different. Let's just make them both integers. There, this will make it a little bit easier to understand. Let's say that I then want this information to be displayed as a float. What I'm going to do, come in here and type float. And you would put in whatever data type you want to show up there. So if you want an integer division to show up as a float, you would do that. And you can see that's exactly what happened. And there you go. And I'm going to leave it with that because that was an immense amount of information on the C programming language. So if you have any questions about anything I covered here, leave them in the questions or comments section below. Otherwise, till next time.